So let's have an overview, a summary regarding experimentation and factorial experiments. So far, we talked about full factorial and fractional factorial. So when we refer to level, many experiments study the combined effects of several factors. In such an experiment, each treatment is formed by combining a specific value, often called a level, of each of the factors. Each treatment factor in the experiment has at least two levels, and this might be the minimum and maximum values, discrete groups, for example, male and female, and designated ranges, for example, ages between 25 and 34, 35 to 44, etc. So for most factorial experiments, each factor has only two levels. This is the simplest designed experiment. Each factor can be set in one of two possible states, and this can be binary, like on and off, 0 and 1, high, low, etc. With two factors, each taking two levels, a factorial experiment would have 4 treatment combinations in total. And this is usually known as 2x2 factorial design. Our next topic is about designed experiments. So we will start with an introduction about what are experiments and what is experimental research. So what are experiments? The term experiments is defined as the systematic procedure carried out under controlled conditions in order to help discover an unknown effect, establish or test a hypothesis, illustrate a known effect. Experiments are used to study causal relationships. In other words, the relationship between cause and effect. You manipulate one or more independent variables, input variables, which are also known as x's, and you measure their effect on one or more dependent variables, which are also known as outputs or response variables. The experimental design may also identify control variables that must be held constant in order for preventing external factors from affecting the results of an experiment. When analyzing a process, experiments are often used to evaluate which process inputs have a significant effect on the process output, what is the target level of those inputs, or what is the target level that we should consider in order to have the desired effects in the process output. Experiments can be designed in several ways, and the objective is to collect this information and draw conclusions. So, on the slide, I have posted a figure. This box represents a process. A process receives inputs and produces outputs. And also, there may be some uncontrolled or uncontrollable inputs that affect the process. So experimental research is the most common type of research design in physical and social sciences, in education, and in other fields, including business. It is the classic scientific experiment, which is similar to the one performed in science classes at high school. The scientific approach to research, where one or more independent input variables are manipulated and applied to one or more dependent variables in order to measure the type of effect they have. The above effect is observed, and it is also recorded over a predetermined period of time. This means that each experiment, like everything else in life, has a start and it has an end. And we design experiments in order to conduct research and come up with conclusions that will help us to improve processes, products, or services. Research design involve collection and statistical analysis of numerical, quantitative data during a predetermined research period. Experimental research is an example of quantitative research method, which is very typically used during the improve phase of the make. This helps researchers draw conclusions regarding the relationship between independent and dependent variables, the X's and the Y's. The types of experimental research design are determined by the way that the researcher, the person who is conducting the research, assigns subject to different conditions and different groups. For example, two samples of the same plant, labeled as A and B, are tested by being watered and treated in the same way. However, plant A is exposed to sunlight, whereas plant B is not. At the end of the plant research period, we inspect the samples and we discover that sample A has grown and looks healthy, and sample B has perished. Therefore, based on the outcome of this type of research, we conclude that exposure to sunlight contributes to the growth of similar types of plants. What is setting? Setting is a term that refers to the location and the environments where the experiment is carried out. Many experiments are carried out in a laboratory where control can be exerted on the extraneous variables, thereby eliminating them. Other experiments are carried out in less controlled settings, and this is the reality in Lean Six Sigma projects. The choice of setting depends on the nature of the experiment that is being carried out. In other words, the environment, the location, the surroundings depend on why we're conducting the experiment. Variables can be classified as dependent variables, independent variables, and extraneous ones. Treatments, which are also known as treatment factors, are conditions of factors and levels. For example, a factor can be temperature, and the level can be 100 degrees centigrade. Each combination is a treatment. So sources of variation can be controlled, and they are definitely of interest. Independent variables can be manipulated and controlled. When we talk about independent variables, we refer to the process inputs, the X's. They are the experimental treatment being exerted on the dependent variable or variables, and a treatment is a specific combination of factor levels which affects to be compared, with other treatments. In other words, we conduct tests and we compare them with other similar type of tests. Dependent variables, depending on the nature and settings of independent variables, and a function. And the function is y equals a function of x. In other words, the dependent variable depends on an input and a function. They're being treated, and they're also known as the subject of research. Extraneous variables are other factors affecting the environment that may also contribute to the change in the dependent variables. And multivariable experimental research may include multiple independent variables such as time, people skills, test scores, etc. We talked about experimental research, and this is the basis for what we call designed experiments. So let's have an introduction to the subject. So what do we need to know before you even start a designed experiment? You must have a general knowledge and understanding of statistics. And SPC, statistical process control, is one of the primary focal areas of Lean Six Sigma. A histogram, which is a frequency distribution, statistical process control tools and techniques, regression and correlation analysis, continuous probability distribution, and analysis of variance. These are the very basics that you have to know and understand before you start controlled and designed experiments. You should also be familiar with at least a statistical software program, such as Minitab, Sigma Excel, Statistica, etc. This can help you expedite designed experiments faster and more effectively when compared with performing manual calculations and analysis. So what are the activities and what are the considerations related to designed experiments? Design experiments involve a number of things. Systematic data collection. We talked about the topic of data collection when we were covering the measure phase of the make. primary focus on the experimental design rather than the outcome and the results. Planning changes in the levels of which independent variables are going to be set. For example, you may plan to set temperature at 100, 110, 120 degrees centigrade, etc. Studying the effect of the above changes on the dependent response variables. Ensuring the results are valid, easily interpreted in business language, and, of course, definitive. The most important concepts in designed experiments are randomization and replication. And shortly, we're going to explain more about these terms. Experimental design means creating a set of procedures to systematically test a hypothesis. Good experimental design requires understanding the system that is under study. And when we're talking about a system, we may also be referring to a process. Experimental design can help the researcher achieve a number of different objectives. Describe how participants are assigned to experimental groups. Minimize or even eliminate confounding variables. And these are variables which can result in alternative conclusions for the experimental results. Allow you to make inferences about the relationship between independent variables and dependent variables, and also reduce variability to make it easier to identify differences in various treatment outcomes. Two common approaches that are used to determine how participants in the experiment are allocated to different groups are randomized design, where participants are randomly assigned to groups, randomized block design, where participants are divided into homogeneous blocks based on common characteristics such as age, sex, ethnic group, etc. So, what are the what, why, and when of designed experiments? Regarding the what, this refers to statistical design methods that can help you determine the best combination of variables to be used in an experiment. And here we're talking about the best combination of independent variables, inputs. In statistical designed experiments, the design is coupled to the data analysis so that each complements the other in order to address the purpose of the experiment. Regarding the why, statistically designed experiments provide more information from fewer experiments than other, less sophisticated approaches like one factor at a time, abbreviated OFAT. The conclusions drawn and the recommendations that are made based on the analysis of desired experiments are more rigorous and have greater validity than any other experimental design approaches. Regarding the when, statistical design should be used Whenever an experiment is carried out, there are very specific designs for comparative screening and optimization experiments. So let's talk about the purpose of designed experiments. In the figure, we have a system. So we have signal factors that entering the system. We have measured responses exiting the system. We also have noise factors and control factors. So DOEs have many potential uses in improving processes and products, including comparing alternatives, identifying significant inputs, factors affecting an output, which is the response, achieving optimal process output, and reducing process variability. Minimizing, maximizing, or targeting an output, improving process or product robustness, and balanced trade-offs when there are multiple critical to quality characteristics that require optimization. We talked about critical to quality, and these are the critical process outputs. Regarding elements of experimental design, using the example of a cake baking process, the following figure illustrates the three elements analyzed by a designed experiment. We have the inputs, also known as factors, controllable or uncontrollable variables. Those parameters that we want to investigate how they impact quality and performance in the output. Levels, also known as settings. So each factor can be set at different levels, and that's why these factors are known as independent variables. And also responses, also known as process outputs, outcomes of the experiment, and these are the process outcomes that you're interested in. For example, in this particular case, in the cake baking process, the factors are the oven, the sugar, the flour, and the eggs. And the levels at which they can be set, in the oven, the levels are controlled by the rheostat, so we can set different temperatures, for example, 200 degrees, 220 degrees, etc. Sugar, we can have a measuring cup. About the flour, again, we can have a measuring cup. And about the eggs, we have to determine what is the number of eggs that we're going to use in the recipe. And in the case of responses, we have a baked cake that is ready to be consumed. And the characteristics of the cake can be described as the taste, the color, the consistency, etc.